It's supposedly recording, so we'll go with it. So, Katie or DW, either one of you want to say anything to get the party started, or you just want to jump into it?
Yeah, welcome to those of you that this is your first time joining us. This is our second meeting of 2023 for the UiPath St. Louis chapter. I'm Katie Adastra. I'm a senior client partner with a consulting firm here in St. Louis. Well, we're national, but I'm in the St. Louis office called Centric Consulting. And I have my colleague on the line as well, David Wilkinson. David, I don't know if you want to say hi real quick. Oh, his audio is muted for him. I don't know how to unmute you. Sorry. I'll try to figure that out. And then Ian, who I'll let him introduce himself. The three of us run the chapter for UiPath in St. Louis. One thing I'll just plug, and I'll be putting this in the chat too, we're always looking for topics. Document understanding was the #1 requested topic when we surveyed folks interested in coming to the chapter. So we are looking for our next topic for next month. So please just put it in the chat, or you can chat directly to me. I'm collecting those so that we can continue to give you content that you're interested in. Thanks, Ian.
No, absolutely. And DW muted. Hey, DW. So, all right, guys, welcome to today's topic: unlocking the power of UiPath, a journey into document understanding. So, before we get deep into those weeds, I will introduce myself a little bit, and then we'll get into some of the content. So, to get things started, my name is Ian Wickline. I'm a senior trainer within UiPath's Partner Enablement Division. Most excited to be here, and hopefully you guys are as well. I'm an experienced IT professional, over 20 plus years in the industry. In addition to my daytime role, I actually serve as an adjunct professor specializing in computer science, information technology, and business management, specifically at University of Missouri St. Louis, or UMSL. I just recently got picked up here locally with SLU, St. Louis University, and Fontbonne. I also have an opportunity to hang out with my alma mater, Millikan University, back in Decatur, Illinois. Let's just say my deep-rooted passion lies in imparting knowledge and witnessing others enhance their understanding or knowledge in a given topic or domain. So with that said, it is definitely a great pleasure and opportunity to be able to guide you through some of the content here this evening. So, long story short, throughout my entire professional career, I've been extensively involved in some form of software development. To date myself a bit, I actually started out on the old legacy mainframe days, up and through fairly recent times, anyways, up until getting into some of the modern day web development as of late, and gotten into some of the various data analytics roles as well. Guys, I got to the point in my career I just burned out. I lost the excitement, the passion, the energy I once had for software development. And fortunately, a few years ago, along came an opportunity that presented itself to where I finally got exposed to UiPath and our UiPath robots. And we'll just say that moment in time, definitely rekindled and revitalized the excitement, the passion that I once had for the IT industry to where I'm at present day today. Prior to actually coming to UiPath, I actually held the position of a lead automation engineer at one of the large Catholic hospital systems here within St. Louis. My role on the team, I was actually accountable for the development of numerous UiPath-based automations. I also had the reins on the solution architecture and design for many, many more UiPath-based automations. In addition to those two hats, I also had the opportunity and privilege of designing and delivering a comprehensive 5-day training program, specifically tailored to educating our new citizen developers. So in the hospital setting, think revenue financial analysts, and yes, even doctors and nurses on how to initiate their first production-based automation. Is incredible to watch, back then, and ultimately brought me to where I'm at presently today here at UiPath. So that all said, let's go ahead and get things started here. So tonight's topic, again, all things document understanding. Here's several of the topics that we will specifically be getting ourselves into. I'll walk you guys through just kind of a broad introduction to what document understanding is. Really just then answer the question, what is it? What is document understanding? We'll get into talking about some of the different document types that we can actually process through the system. A couple of different methodologies that are used when using document understanding. Get into introducing this idea of model-based versus rule-based extraction methods that are out there. And then really just talking about that whole end-to-end automation process, what that looks like, and start getting into what a typical document understanding workflow and all the different components and pieces that allows us to get through the actual process. We'll introduce briefly the idea of classification and extraction, the success criteria. So there's kind of some built-in systems and methods that we can use to really validate, the content that's been extracted out of a document. And we'll talk about some of the components and pieces there. Kind of tied into that success criteria, we'll actually look to a specific use case called invoice post-processing. And when it comes to talking about the classification and extraction, and we'll do a brief little dive into looking at some of the just kind of the broad architecture the document understanding platform can be deployed and sits upon. So what in the world is document understanding? Let's just sum it up by saying it's a powerful tool designed specifically for processing documents intelligently. The main purpose trying to enable our UiPath robots to understand the content and structure of documents using a combination of rules, templates, potentially some artificial intelligence powered skills, all about trying to allow for the efficient, accurate data extraction from various different documents that we might need to be able to process, in all of our respective practices. So with document understanding, one of the cool things is this idea of being able to leverage artificial intelligence, technologies, getting into some natural language type processing or OCR, optical character recognition, and even getting into some raw machine learning, type capabilities, trying to teach our robots how to analyze and comprehend different documents. So through all these artificial intelligence capabilities, trying to enhance the robot's ability to be able to extract valuable information or content, especially when we get into what we start talking about unstructured and semi-structured documents, such as invoices, purchase orders, contracts, and much, much more. We'll get into a little deeper dive as to what these specific document types are. So the process of really teaching the robot to understand documents begins with really creating rules or templates or what we call skills. And the rules are really they're predefined instructions trying to guide the robot in identifying specific data points within a document based on patterns or potentially keywords. The idea of the template, try and provide a structured framework, that defines the layout of the expected data fields of a particular document type, making it easier for the robot to be able to extract, the relevant, the critical information, as accurately as possible. Skills, on the other hand, utilize AI algorithms and actual models to recognize the document, be able to interpret complex data structures within the documents that we're ultimately trying to extract data from. So once all the rules, templates, and skills are defined, then we can then seamlessly integrate those directly into our UiPath Studio workflows. And that integration is achieved through really our drag and drop, like we've always done, where you simply add the different document understanding capabilities as the activities directly into the workflow. So something that we're all really and accustomed to. So nothing really changes from that perspective. So by combining the artificial intelligence and RPA inside a studio, the idea of being able to automate the document processing tasks, that previously would have required significant manual effort. So through the use of artificial intelligence and the enhanced capabilities of document understanding, trying to enable those robots to handle those unstructured documents with precision, extracting the relevant data fields and do the validation, making sure that all the key critical information has been extracted. Let's go to the next slide. There we go. So document understanding, referring to that capability of extracting and interpreting information, and meaning from diverse types of documents, encompassing, that wide range of technology and methodologies, trying to enable automated systems to analyze and comprehend the contents of documents, regardless of their format or structure. So the ability, what we're talking about is that integration of document processing, artificial intelligence, and robotic process automation techniques. So at its core, document processing involves the handling, the manipulation, the analysis of documents in a digital form. That'll become an important content point here in just a moment. including tasks as capturing the document, storing it, the retrieval, the transformation, and then obviously then the dissemination on the opposite side. All the document processing technologies enabling organizations to manage large volumes of documents efficiently, and accurately. Artificial intelligence playing the pivotal role in document understanding. Why? Because it provides those advanced capabilities for data extraction, comprehension, decision making. AI techniques, again, we mentioned it, natural language processing, machine learning, computer vision, all employed trying to analyze, the content and structure of the documents, looking for patterns, being able to extract the relevant information that's needed for our broader business process. So obviously all these techniques and, enabling the automated systems to be able to interpret that unstructured to semi-structured data, transforming it into structured data that then we can then actually process and utilize more efficiently in our RPA, projects and workflows. So RPA in the game here complements document understanding by automating that repetitive and rule-based tasks that are related to document processing. RPA technology utilizing our software robots, again, trying to mimic those human actions and interactions with the digital systems. So by leveraging RPA, obviously being able to automate the tasks such as our data entry, data validation, the different document classification that's going to be needed, and then obviously the data extraction from the documents. So the convergence of document processing, AI, and RPA and document understanding, trying to empower organizations to streamline our document intensive processes, trying to enhance the data-driven decision making, and ultimately drive the digital transformation that's needed at hand. So depending on the structure and the formats, so getting into more of the document types here, there's really 3 different types of documents that will kind of classify into the whole document understanding world. Structured documents, semi-structured documents, and unstructured documents. So to go into a little more detail on each of these. So structured documents, referring to documents that have a very consistent format. The required information is typically located in the exact same place within each document. Structured document, the fields or data elements that need to be extracted are very well defined, are often very well defined, and have very specific or explicit locations within the document. Think about a structured form that you might work with. The name and address fields may always appear, in a certain location. The date field might appear in a particular, explicit, repetitive, consistent location. The idea is, that fixed format of structured documents allowing for efficient data extraction. The rules can be designed to locate and extract information because of their known positions on a document. They essentially follow a predefined template or layout, making it easier to extract the necessary data accurately. A couple of things to maybe resonate towards what type of documents are we talking about. Think about forms, passports, different licenses, maybe timesheets in a time card type environment. Something along those lines would be common things that you might see on more of a structured document. Starting to shift our way towards unstructured, this idea of a semi-structured document, where we're starting to talk about having a document that's really kind of got a mixture of fixed and variable parts within a document. Some of the sections, might be consistent. Again, tables, headers, different parts, along those lines might vary though in their content or layout. But again, you're dealing with a table of data or a section of data. The required information in a semi-structured document, it's still repetitive in nature, but it might be found in different locations or sections from one document to the next. So a lot of times when you start thinking about documents that kind of fall into this category, think about invoices, receipts, purchase orders, medical bills, bank statements, utility bills. Think about invoices. They all really have predefined sections, right? The vendor name, invoice number, line item, in a given table. However, though, the number of line items, it might vary, from invoice to invoice. So trying to extract data from a semi-structured document, might require identifying and capturing, those relevant data points or information from both fixed and variable-based sections. So you can see how it changes slightly in context. And then on the far extreme, the world of unstructured documents, where they don't adhere to any specific formatting or layout at all. These types of documents lack any form of consistent structure, making it very challenging to locate and extract the desired information automatically. Unstructured documents often contain free-flowing text, paragraphs, or sections of data that may have, complex content or formatting attached to them. A couple of examples of unstructured documents, things to think about here. Think about contracts, different types of agreements that might be out there. Think about emails, maybe in the healthcare world, disease descriptions, drug prescriptions. And think about news articles and even voice scripts. That's all the world of unstructured documents. Extracting data from unstructured documents typically will involve applying advanced techniques such as getting into natural language processing and text mining type capabilities. These techniques trying to analyze the content and the context of a document to try to identify the relevant information. In the case of unstructured contracts or agreements, for instance, think about how the system needs to be able to comprehend the text to be able to extract clauses, or maybe who are the key people involved in the contract, particular dates of the contract, and obviously any of the other critical details that might come out from that as well. The natural language processing algorithms, trying to utilize and parse and understand the text, enabling the extraction of the meaningful data from those unstructured documents. So, obviously more complex requires, advanced algorithms, techniques, compared to structured and semi-structured documents. So how do we go about then extracting all this data? We really got 4 different options from a document processing methodology point of view. Different types of extractors, as we call them, to handle the various types of documents to extract the information accurately and efficiently. The extractors are really categorized into rule-based extractors, model-based extractors, and then we also get into this idea of utilizing a hybrid approach of the two. So let's talk about each one in a little more detail. This idea of a rule-based extractor. The idea of a rule-based extractor is relying on really a predefined pattern or rules to be able to extract information out of a structured document. So there's your key there. We're talking about structured documents when we get into rule-based extractors. So 2 of the common rule-based extractors are available inside a document understanding. One, we call it the regex-based extractor. And just kind of almost speaks for itself here. We're utilizing regular expressions or regex to identify and extract data based on specific patterns at that point. Obviously particularly suitable for structured fields within the document. Regular expressions allowing obviously for that powerful pattern matching, and then making it effective in being able to extract data within consistent formats. As opposed to the form extractor, which is designed to handle mostly structured documents, especially forms, hence the name form extractor. The idea of being able, with these forms containing tables or checkboxes, handwriting, signatures, essentially using a combination of OCR, optical character recognition, and intelligent algorithms to be able to extract data from these documents accurately. As opposed to the opposite when we start to look at model-based extractors. So model-based extractors, essentially, the long story short here, leveraging machine learning models to automatically understand and extract information from a document. So document understanding provides us 2 different approaches here of model-based extractors. The first one is called Forms AI. Forms AI kind of sits in the middle, if you will, the rule-based extractors and the full-fledged machine learning extractors, kind of the easy way to think of Forms AI. Specifically designed to handle structured documents still, again, such as forms, but utilizing pre-trained models and machine learning algorithms to recognize and extract data fields from these documents. So Forms AI can accurately identify fields like names, addresses, dates, other structured type content. Notice it's not doing anything unstructured here. As opposed to a full-fledged machine learning extractor, again, suitable more for those semi-structured documents, again, that mixture of structured and unstructured data. Again, utilizing machine learning algorithms still to classify and extract data from these documents. So the machine learning extractor, all about learning from labeled training data. and be able to adapt its extraction capabilities based on those previously provided examples. So now we got rule-based, model-based. We also have this idea of bringing in this hybrid approach, essentially combining the strengths of both rule-based and model-based extractors. So we can actually bring the best of both worlds together. Allowing the RPA developer, to leverage rule-based extraction for the structured documents. Obviously, you can even say the structured aspects of documents, and then the model-based extraction for those less structured documents within a single workflow. So you can mix and match these as we go along. Obviously, this approach is definitely useful when we're dealing with documents that contain both structured and semi-structured documents. So all that to say, document understanding obviously provides a wide range of different extractors to be able to handle different document types. So you essentially got to map them up. Rule-based extractors, the regex form extractor, structured documents. Model-based forms AI machine learning extractor. Obviously, being able to handle structured, semi-structured documents, respectively. And then obviously the hybrid approach, being able to combine the rule-based and model-based to be able to handle documents, with that mixture of structured and less structured formats. So, getting into talking about, model-based versus rule-based extraction, when using UiPath Document Understanding. So obviously rule-based extraction, that template-based approach, again, relying on rules or templates. Rule-based extraction, predefined rules or templates to identify or extract data from those documents. It's great at processing documents that are in a very fixed format. Think forms or driver's licenses or different types of licenses. Has a high accuracy, when we're dealing with already known documents. Again, that's got consistent patterns. Why? The rules are designed specifically for these documents. And then obviously we can fine tune them to obviously try to achieve those precise data extraction. Anything that would require, extra cost, additional templates, rules, or ongoing maintenance. So, implementing rule-based extraction, it requires the creation and maintenance of templates or rules for each document type. And obviously this process is going to involve additional costs. Why? Because we're going to, you got to have somebody that's knowledgeable of the different, documents, the analysis, and the rules creation that's needed, plus in the ongoing maintenance that's needed to be able to update those rules or whenever the document formats might potentially change. The one thing that you got to consider here, obviously, it's unable to work on unknown documents. Rule-based extraction is limited to working on documents that adheres to predefined templates or rules. So when a new rule or an unknown document's encountered, the extraction process is going to fail, or may potentially fail. Might provide inaccurate results. Rule-based methods, they lack that flexibility, to adapt, and understand the different document layouts or structures. So they're very fixed. As opposed to our model-based extractors, or what we could really refer to as template-less approach, all about, again, working with machine learning models to automatically learn the patterns in our documents and the different features of each document. These models are trained on large data sets, trying to generalize their understanding, to process each document with varying layouts and different structures. Model-based extractions, very well suited for documents that have less predictable layouts. Again, invoices, receipts, contracts are kind of the common ones. Documents that are, have varying formats. Obviously, the machine learning models got that capability to be able to analyze, the content and context to identify the relevant data points accordingly. Be able to understand even the most obscure and complex documents. Again, since we're working with machine learning models, those machine learning models can be trained to recognize those patterns and relationships within the documents. Again, trying to enable them to extract data accurately, even from challenging documents that are with unconventional layouts. One of the cool things with machine learning models, got a catch-20. They require that the model be pre-trained, but they also provide us the option, or depending on the model that we utilize, the ability to further retrain the model as well. So anytime we get into model-based extraction, we have to essentially label the data sets up front, label the documents, essentially build out these data sets so the models can be trained, they can learn on how to actually extract the data. These pre-trained models, they could be fine-tuned, retrained. Obviously, certain ones can, certain ones can't. Using additional labeled data, essentially, be able, be specific, to the desired document types, the different documents that we're trying to get out. What's awesome though with retraining is that's where we can then actually improve the accuracy and the adaptability of models, to meet the specific extraction requirements. So how does this really start to all come together? Now that we kind of outlined what the possibilities or capabilities are, let's start talking about more of that broader architecture for an end-to-end business process involving document understanding. The architecture really follows what's known as a one job per file architecture, essentially processing a single document at a time. There's really, with that said, there's three components as we're processing a single document at a time. We've got what's referred to as the upstream automation. This would be obviously the work ahead of the actual document understanding process. Then we actually have the document understanding process. And then on the flip side, all the downstream automation that comes out of, if you will, the document understanding process. And the idea or the architecture designed to handle the entire life cycle of document processing, all the way from the initial automation tasks through the data extraction, and then obviously anything that we're going to do with that extracted data downstream. So what are we talking about? Upstream automation. This particular component serving as that initial stage of the larger business process. Encompassing all the business logic, all the automation tasks that are needed to be executed before the document understanding work can take place. Typically what you'll see here would be one or more RPA processes handling tasks such as, retrieving the needed documents, preparing the documents, preparing the files, whatever it might be, and then any necessary pre-processing that might be needed before we actually go in and attempt to capture the information or content out of the document. Think of this as really the upstream automation as acting as the dispatcher for the document understanding jobs. Might help to resonate a bit more that way. Sending the files to be processed into the document understanding process. And then you've got the actual document understanding process. The core components of the architecture responsible for extracting the data from the documents and performing the necessary analysis. Again, think of this now as the performer from the upstream process, by receiving the files that need to be processed. And then obviously within our document understanding process, all the different steps that we're about to get into here in just a couple of moments, classifying the documents, extracting the content, as well as some of the back-end validation as well. Again, document understanding, we've talked about leveraging the machine learning. That's where all this magic starts to happen. And ultimately the output from here, the extracted data, is then passed on to the downstream automation component. Again, where it receives the extracted data. Similar to the upstream automations, the downstream obviously is going to be one or more RPA workflows or processes trying to utilize the extracted data from the documents to be able to carry out specific actions or decisions here. So the downstream automation, really think of it as the performer from the document understanding jobs, if you want to think of it kind of through that lens. Taking the extracted data to drive subsequent steps in the business process downstream now that we've got the data extracted. Things to think about here might be, maybe we're just doing some database updates. Maybe we're generating some reports, triggering some type of alerts or notifications to some downstream process. The sky's the limit here. Any other task that might be dependent on that extracted data, that's where that magic starts to happen right here. So how does it all start to come to life? This is probably, if there's an important slide all day long, that's this particular slide here. This is the holy grail of document understanding right here. What does a typical document understanding workflow look like? A document understanding workflow consists of many steps that are designed to process our documents, extract the relevant information, make it available for the downstream automation process that we were talking about just a moment ago. So of all these steps, we start out by going through and loading the taxonomy. This idea of loading the taxonomies, trying to define the document types and the fields. Think about the individual data, elements, content that needs to be processed. Essentially, kind of acts like the blueprint for our subsequent steps that we're about to start talking about here in just a couple of moments. So by defining the document type and the fields of each of those respective documents and the types of documents, essentially the taxonomy is trying to help and organize and structure the document processing process that we're about to embark on. So once we've got the taxonomy loaded, we go through a step known as digitize. Once the taxonomy is loaded, we digitize the documents, typically utilizing optical character recognition here, being able to convert the physical or scanned document into a machine readable format. OCR obviously trying to enable the extraction of the text and text from our images or scanned documents, making it possible to work with the content of the documents in a digital form. Once we digitize, then we get into a classification process where we try to split the documents into their different document types based on the content characteristics of each document. The classification step trying to aim to categorize each of the individual documents into their appropriate document type defined back in the taxonomy. Classification can be performed utilizing various techniques. One that's probably most common, a keyword matching mechanism. You can get into doing some work here with machine learning algorithms as well, or some type of custom rule as well. But the classification step, it's crucial, it's critical here. Why? Because then it's going to determine the subsequent processing logic that's needed for each of the document types moving forward across the typical workflow. After we classify the document, then we can essentially validate that classification through a human review process if needed. This step essentially involving the reviewing the classification results, making sure that the results, the robot's attempt at classifying the document, how accurate was that process? Essentially, to say human validation may potentially be required here if that confidence or the result of the document classification falls below a certain threshold. At that point, then we can involve the human review. Handle any misclassifications or errors at that point, be able to identify them, correct them before we continue on with the rest of the workflow. And then also one of the other cool things here is we can actually improve the overall accuracy of the system kind of long term. And that's what gets us into the whole idea of training the classification here. So based on that human validated data that we did in the validating of our classifications, the classification models can be updated, trained, retrained, to improve the accuracy based on that human, validation. These steps here, taking that feedback, the corrections provided by the human, during that validation step, being able to update and refine the classification algorithms accordingly. So obviously training the classifiers, trying to help the system learn, from human expertise, improving the ability to hopefully accurately classify those documents, the second and subsequent times on down the road into the future. So once the document has been classified, validated and trained, if you will, then that's where we can finally step into the extraction. The extraction step focusing on extracting the relevant information out of the documents. Specific data fields, the names, the dates, the addresses, any of the other structured or unstructured information based on the document type and the field definitions that we loaded back in the taxonomy again. The extraction techniques obviously can vary depending on the nature of the information that's being extracted. Pattern matching, rules-based extraction, some of the more advanced natural language processing methods, a little bit of what we've talked about, prior. Once we extract the data, very similar to what we did with the validation step in our document classification, the extraction results also get validated or can potentially be validated through a human review process. Human reviewers, much like what we just talked about, being able to validate the accuracy of the extracted information and compare it against the original document. If the confidence level of that validated result falls below, again, that certain threshold, the human review, correction may potentially be necessary. Why? Because we're trying to ensure the quality and accuracy of that extracted data as we continue to work our way downstream. So after the human gets involved, we've got the ability to then train or retrain the extractors. Again, similar to what we did with the classification a moment ago. Now that we're talking about the actual field level extraction, trying to update the extraction algorithms using the feedback and the corrections provided by the human, during the validation process. So we can, again, train the extractors, allow the system to be able to learn from the human expertise again, be able to enhance its ability to accurately and extract the information from documents moving forward. And once we have everything extracted, we finally get into the export step. Essentially the final step of the document understanding workflow, where we can then export the extracted data for further usage in the downstream automation process. The extracted information is typically made available in some type of structured format, CSV files, JSON, JavaScript object notation files, ultimately being able to easily consume them by other automation systems, databases, applications downstream. Again, trying to allow that extracted data to be utilized for the various purposes. Populate forms, update databases, driving decision-making processes, whatever it might be. So to kind of bring it all to holistic here, UiPath Document Understanding workflows encompassing obviously a wide series of steps. Loading the taxonomy, going through that digitizing, classifying, extracting, validating, and then ultimately exporting data on the far extreme. Obviously, each of these individual steps play in a crucial role in that overall document processing of the whole holistic, if you will, automation journey, making sure that organizations can efficiently handle large volumes of documents, extracting the necessary and valuable insights, and being able to drive, again, those downstream automation processes accordingly. Let me pause here for a moment. Katie put a little plug out here. Comments, questions, thoughts, concerns before we continue on with the journey. How's everybody doing?
I'm good.
Awesome. Awesome, awesome. All right. So this idea of classification and extraction success criteria. So within the document, kind of take it even a step broader for a moment, then we'll get into the weeds here. So in the world of document understanding, obviously the processes related to document understanding, they've got a distinct logical flow, very specific requirements that obviously make them better suited to have their own framework rather than relying on the existing RE framework that we've all have grown accustomed to. So there is its own, or I should say, there's its own framework, if you will. There's an RPA framework for document understanding, which is really aimed at providing a structured approach for handling document processing tasks. And one of the key components that I'm going to highlight here that's built into this framework for document understanding is a feature known as classification and extraction success criteria. This feature plays a very vital role in determining the success of the classification and extraction steps that were performed on the documents, trying to ensure the accuracy and reliability of the automated document processing. So to go into a little more depth and detail here. So after both the classification and extraction steps have completed, there's essentially a set of dedicated workflows that you can essentially interpret, the business rule validation here. So in the document understanding process, specific workflows designed to validate, the extracted results, obtained from the classification and extraction steps accordingly. These workflows trying to implement business rules that are relevant to the organization's requirements. The purpose of this particular step to try to ensure that the extracted data and the assigned classification are correct and aligned with the expected outcomes. So by incorporating the business rule validation here, you can actually perform additional checks and verifications on the process documents, all about trying to enhance the accuracy, reliability of the automated document processing here. So with that said, based on the outcome of the validation of the from the workflows, essentially a decision needs to be taken. Whether the document will be set for human validation or fully able to automate all the way through without bringing that human in the loop. Once the business rule validation has been executed, the outcome of the workflow is, trying to evaluate to determine whether the document's going to require that human validation or not. The decision's typically based on some type of predefined criteria, rules that have been, essentially been established during the design of the document understanding process. If the validation results, meet the specified criteria and pass all the necessary checks, the document's, considered accurate and reliable enough to proceed without bringing the human into the process, human in the loop, as we call it. However, if the validation outcome indicates that there's potential rules issue or potential, whatever that issue might be, or doesn't meet those predefined checks, the document's flagged and the human's able to come into the loop, where essentially a human operator gets, introduced to the process and can review and verify the extracted data and classification, essentially used a manual process at that point. That also said, if we, totally discard and we don't implement any logic here at all, essentially that's going to have all the documents essentially by default be sent for human validation. So to maybe bring this into a little more real to life type of a context right here, think about an invoice for a moment in the whole world of the document understanding framework. Especially with what we're talking about here, the whole classification and extraction success criteria feature that we just talked about on the previous slide. Think about a handful of different business rules that might be needed or utilized, when validating, a standard invoice, a standard workflow for invoice processing here. So one of the things that you might consider checking is, a verification that all the mandatory fields and columns have been successfully extracted. So essentially setting up a rule that ensures that all the essential information that's required for our broader invoice process, maybe it's the invoice number, vendor details, the invoice date, maybe some of the line item details, etc., whatever it might be, we're checking here. Have they been correctly extracted out of the document? Essentially the workflow being able to validate that none of the mandatory fields or columns are missing, from the extracted data. Assuming we kind of get by that check, then we can go in and actually begin to verify, let's think about the line item details. The table of line items, if you want to think of it that way, match a particular rule. So think about the quantity times the unit price equals, the extended line amount. You'd expect to have that mathematical expression come true for each of the individual line items. And it's essentially talking about having a rules check here that validates, that each of the calculated line items, quantity multiplied by the unit price, matches, the expected and the extracted line amount. So obviously, if that mathematical calculation fails, then we obviously didn't have an accurate extraction of the line item information. Kick that out potentially and send it over to the human, for manual validation. Kind of similar idea, verify that the sum of all the line amounts equals our net amount. So getting into the grand totals, the same type of concept again. If the sum of all the individual line items doesn't correspond and match to the net amount, probably need to kick the document back out and have the human in the loop come into the table. We've got some data validation issues. Verify the sum of the net amount and all the fields determined on the subtotal, match the final total. So again, getting into actual data validation here. One of the things that we kind of glossed over in our demonstration here tonight, the idea of extraction confidence is another another value that gets exported out of the process. But essentially, it's a scoring mechanism, if you want to think of it that way, that essentially allows for the robot, and not so much even the robot, the ability of the machine learning algorithms to essentially flag its confidence that it was able to successfully extract the data at that point. So some of the invoice processing scenarios are going to involve what's known as a confidence level, based on specific fields of the extraction. Essentially, this rule looking at that confidence score, typically what we'll refer to as the confidence field, against the corresponding threshold. So it's essentially the threshold's a value that we ultimately set based on our confidence of how well the machine itself is performing. So it's important to emphasize, obviously, the handful of rules that we've got here, kind of being that starting point, specifically in this case for invoice processing, you're going to need to adapt and tailor, these types of rules to the specific needs of each of the individual business processes that you ultimately are trying to implement through the whole document understanding process. Obviously, all these real world implementations going to require additional rules, custom validations, adjustments to be able to suit the individual unique processing requirements of the organization. So from a broader architectural type perspective, we really have the ability to utilize several different architectures, trying to provide the flexibility, scalability of the document processing task at hand. So we can essentially deploy in a handful of different ways. Full on-cloud architecture, so essentially utilizing UiPath Document Understanding, leveraging the cloud-based architecture. Thinking about public services, cloud tenants, and so on. Obviously, trying to provide that seamless integration with other cloud services. The scalability, reliability, accessibility that obviously is offered up through such a platform. Document understanding can be deployed in an on-premise architecture as well. So obviously, kind of, I guess, going a little bit further there, we could go either in an online or an air gap type mode, obviously depending on a lot of times the data security needs, compliance needs that might be in existence within a given organization. Again, give you guys obviously a lot more control, complete control over the actual document understanding infrastructure, and then obviously getting into more of the air gap side, the whole data privacy component as well. Or you could obviously go into more of a hybrid type of an approach, having to leveraging and benefiting the best of both worlds, advantages from deploying to cloud, as well as obviously being able to deploy locally as well. So to kind of recap, bring things to a close, we have no doubt embarked on a journey into the world of document understanding this evening, hopefully unlocking the immense power, obviously, that the platform holds for automating document processing. We've explored the different capabilities, the different document types that can be sent through, all the different methodologies that we can employ to extract some of the key and valuable needed data, as well as obviously talking about model-based and rules-based extractions, understanding how each of those obviously both shape the efficiency and accuracy of the process. But understand, obviously, document understanding is obviously just more than a standalone tool, right? It's definitely a vital piece of the puzzle of achieving that end-to-end automation. And hopefully you guys saw as we've gone through, how it seamlessly integrates the workflows, working hand in hand with other automation tasks, all about trying to drive transformative change within our respective organizations. We dug deep into some of the typical workflow document understanding. We witnessed all the different steps involved in the document ingestion, the classification, the extraction of data, leading obviously to the pinnacle success criteria, being able to accurately, efficiently, scalability wise, the adaptability, all the different pillars upon which document understanding rests itself upon, elevating businesses again, hopefully to the new heights, the product, productivity and excellence. So what a better way, obviously, to illustrate capabilities, with concrete example. Obviously, we explored document understanding, being able to revolutionize, invoice post processing, liberating organizations, that tedious manual data entry. Obviously, with its ability to be able to extract and validate information, seamlessly. That's obviously the be-all, end-all goal. Being able to pave the way for, streamlined operations, reducing the errors, drive efficient integration, obviously with a multitude of systems. So, one of the last things that we kind of looked at, obviously unraveling the different architecture platforms the document understanding can rest upon, being able to present, different choices, obviously to suit different specific needs within respective organizations, on-prem, cloud-based, ultimately, maybe even the hybrid type model and how, that seamless integration plays out with some of the other systems. Guys, the possibilities, they're boundless. And obviously the potential for growth here is beyond infinite. So as I kind of come to a close here, obviously to kind of reiterate again, document understanding is not just a tool. Document understanding is a huge catalyst for transformation, empowering businesses to liberate valuable time and resources, enabling everybody to develop focus on the strategic initiatives, the innovation and growth. So dare to embrace the power of automation, guys. Embrace the potential of document understanding. Unlock a future where efficiency and success converge. Thanks, guys, for joining on this captivating journey. And may your respective paths to automation be illuminated by the brilliance of document understanding. And in typical UiPath spirit, happy automation. Guys, thanks so much. It's been a pleasure to hang out with everybody today. David, DW, got a question. Do you have any examples of document types that should not be pursued for this technology? The short answer is I would say no to it. The sky is really the limit. The challenge, though, that you are going to have, obviously, the more complex the document gets, obviously the training and then the educating that you got to do on the machine learning models to get it to a point of success. That's going to be the epitome, I guess. If there's a negative component to it, that's where it's going to be at. But when you get into the truly structured documents and get into some of the form extractions, you should not encounter much of a problem or issue from that stage. But the more unstructured a document gets, that's where the challenge and the complexity ultimately stems at. So, and then yes, Katie's got another reminder in the chat window. Share your topics of interest for future meetings. Yes, that's how we landed on today's topic. So if there are particular topics that you would be interested in, please do feel free to email those across, drop them in the chat window. We will definitely be glad to entertain future topics down the road. As of this very moment, we don't have another live session scheduled, but we will definitely strive to get something on the books for kind of mid to end of August, and to make sure that we're hitting the marks on topics that you guys are interested in. Please do float those across, and we'll definitely get those on the radar for our August meeting. That said, I am done if and only if you guys are done. So again, it's been an honor, privilege, and pleasure. All the best, everybody. And again, happy automation.
Thanks, Ian.
Absolutely. All the best, guys.
Have a good one, everybody.
Yep. Cheers, all.